The Boltzmann brain of the universe. Have you ever wondered how this whole vast universe in front of us came to produce us as thinking, feeling beings? To many physicists, it all seems to be the result of the spontaneous emergence of natural laws over a long period of evolution. But a rather bizarre idea has emerged, perhaps, in the endlessness of time and space. Random thermodynamic fluctuations are enough to allow a consciousness to appear out of thin air, even if it is only transient and isolated. This is the core concept of Boltzmann's brain. This was the core concept of Boltzmann's brain. Back in the late 19th century, physics was in the midst of an explosion of ideas. At that time, thermodynamics and statistical mechanics were gradually revealing the laws behind the motion of microscopic particles, explaining why matter always has a tendency to move toward higher entropy, i.e., more chaotic, states. It was against this background that the Austrian physicist Ludwig Boltzmann put forward a series of ideas that seemed highly philosophical yet full of mathematical rigor. He argued that the universe is actually in a constant state of equilibrium, and that the seemingly orderly phenomena are in fact the result of transient statistical fluctuations. Imagine, if the universe is old enough and big enough, then over a long period of time, just by virtue of random fluctuations at some point in time, a certain region will accidentally form a complete brain. And even those seemingly coherent memories will also be generated. This brain may think that it has experienced a long and real history of the universe, but in reality, it is just a thermodynamic product of a momentary spontaneous flash. Doesn't that sound incredible? But this is exactly what scientists have deduced based on probability and statistical analysis. In order to better understand the Boltzmann brain, we may first talk about Boltzmann himself and his time. The late 19th century in Europe is the era of scientific and philosophical discussions. At that time, people tried to unravel the mystery of nature with math and experiments, and Boltzmann was one of the leaders. He not only studied the motion of gas molecules, but also proposed the concept of entropy, which explains the second law of thermodynamics. That is, entropy always tends to increase in a closed system. Interestingly, Boltzmann, in the process of exploring the laws of the microscopic world, also realized a seemingly paradoxical phenomenon. Despite the fact that the laws of physics are completely symmetrical, we observe that time always flows in one direction, and that memory and causality always unfold in one direction. As a result, people began to wonder whether it was possible that over a long enough timescale, random particle motion could, by chance, assemble a seemingly ordered structure, or even a self-aware brain, out of chaos. This question has been widely discussed since it was first raised. Many physicists, cosmologists, and even philosophers have begun to think, if the universe can really generate such a brain, by chance out of disorder, what is the reality that we experience and feel today? In fact, a number of scholars have cited Boltzmann's ideas to explain why the universe we see is still so organized on a large scale, rather than being in a state of total chaos brought about by increasing entropy. You can also visualize the matter like this. In a huge casino, all bets are random, and extremely rare combinations are possible with every roll of the dice. Only, in this gigantic casino, the stakes are the existence of everything in the universe, and the random fluctuations are like countless rolls of the dice. Most of the time, the results of the dice are within the expected range, but occasionally there will be those staggering, abnormal results, such as a suddenly formed brain with complete memory and consciousness. This is known statistically as a very low entropy fluctuation. Simply put, when the entropy of a system is at its highest most of the time, there are occasional extremely rare low entropy states. But as you can imagine, if such fluctuations were simple enough, such as piecing together an isolated brain, the probability would be much higher than making an entire organized universe. In other words, the probability of randomly generating a brain in a long, sufficiently large universe is much higher than generating a universe as vast and orderly as the one we have before us. I remember once an academic explaining this idea at length. You see, if we accept such probabilistic logic, then the real world may not be what we think it is. Perhaps most of the observers in the universe are actually brief flashes of Boltzmann brains that just randomly emerge from the sea of entropy to act out a play on the history of the universe, along with false memories. Hearing him say this, I couldn't help but ponder, if we ourselves might just be the product of this random generation, how can we rebuild all our trust in the past, in causality? Because Boltzmann's conception of the brain raises a seemingly absurd possibility, many scholars have begun to reflect, if most observers are in fact fragments of this randomly generated consciousness, can what we now think of as the universe, our memories and our histories, be considered real at all? Some famous philosophers and physicists, such as Sean Carroll and David Albert, have discussed this question in public lectures and papers. They have pointed out that if a theory predicts that the vast majority of observers over a long period of time are simply Boltzmann brains, then the state of the universe we live in is in fact highly unlikely. Because we see a universe that is far more coherent, rich, and organized than a memory that a contingent brain can make. In other words, if the Boltzmann brain were too common, we would instead find ourselves experiencing fleeting, rootless flashes of consciousness, rather than a complete self with a full set of historical records. This paradox is one of the focal points of modern cosmological and philosophical discussions. We tend to think that our memories and histories as conscious individuals are reliable and based on real causal chains. However, if randomness can create isolated brains with complete memories, then our existence is clouded in a fog, as if everything is an illusion woven by statistical chance. This view not only challenges our trust in reality, but also makes us wonder what is truly meaningful on the infinite scale of the universe. Interestingly, there have been a number of similar discussions throughout history. For example, the famous astrophysicist Alan Guth once quipped, "If the brain can emerge from the sea of entropy at any time, then we would prefer to choose to believe that we have a continuous course of life rather than occasional flashes of a bubble of consciousness." This sense of humor is a reflection of the scientists' attitude of not forgetting to laugh at themselves in the midst of serious discussions, as well as their helplessness and awe at the deeper implications of the issue. After entering the 20th century, with the development of cosmology and quantum mechanics, people's understanding of the evolution of the universe has deepened. Especially at the end of the 20th century and the beginning of the 21st century, with the introduction of the theories of dark energy, dark matter, and cosmic expansion, the discussion of time, space, and entropy in the whole cosmological community became more complex and diversified. Against this background, the question of Boltzmann's brain has been raised again and has become an important criterion for testing the rationality of certain cosmological models. For example, in the discussion of the hot silence problem, many scientists pointed out that if the universe will eventually reach a state of thermal equilibrium, and Boltzmann's brain will occasionally appear before that, then the universe we see today seems to be extremely abnormal. This is because, by probabilistic calculations, the likelihood of randomly generating a complete universe in an infinitely long universe in a state of thermal equilibrium is much lower than the likelihood of generating an isolated brain. In other words, if our universe were the product of chance in such a state, then we should be highly likely to be a Boltzmann brain in a flash, rather than a normal observer with a coherent history. In this regard, the famous physicist Sean Carroll once said in a public lecture, "If you believe a theory that predicts the universal existence of Boltzmann brains, then you have to deal with the fact that you are statistically more likely to be a transient bubble of consciousness than a human being with a continuous memory." This statement had caused an uproar in the academic community because it not only challenged the very foundation of our perception of self, but also questioned the rationality of cosmological theory as a whole. At the same time, other scholars have approached the issue from different angles, trying to prove that our universe is unlikely to fall into this Boltzmann brain flood. For example, some cosmologists have proposed the degenerate probability, or self-consistency principle, arguing that a plausible model of the universe must be able to guarantee large-scale structure and historical continuity, and cannot rely solely on extreme statistical fluctuations to creating observers. As physicist André Linde points out when discussing the theory of eternal expansion, a healthy model of the universe must not only account for the observational data in front of us, but also avoid the kind of self-contradictions triggered by probability theory. Talking about the Boltzmann brain brings up the key elements of consciousness and memory. After all, a being that calls itself a brain must have a continuous stream of memories and self-awareness, in addition to a basic neural structure. This is a proposition that philosophers have long explored. How reliable are our memories? Are our recollections of the past really the result of our own experiences, or are they merely illusions within the brain? Many philosophers have used imaginative metaphors to discuss this question. For example, the famous thought experiment, box inside the brain, is similar to the Boltzmann brain. Imagine if one day you realized that your memories could be generated by some random mechanism. How could you be sure that your experiences were not the product of some clever program? This point is reminiscent of the plot of the science fiction movie, The Matrix, as if each of us is just a program temporarily running in the system, and the so-called real world is just some kind of hallucinatory set. More interestingly, the fields of psychology and neuroscience have begun to focus on similar issues. In recent years, with the rapid development of brain science, a number of experiments have shown that memory in the brain is in fact very susceptible to interference by external factors and internal random noise. As American neuroscientist Eric Kandel mentioned in an interview, our memories are not static videotapes, but are the product of constant reconstruction and modification. If we think about this idea in relation to the Boltzmann brain, we might realize that it is entirely possible for a brain, even if it is randomly generated, to construct a seemingly coherent past and thus convince itself that it once had a complete life experience. This view undoubtedly throws a wrench into traditional notions of the law of cause and effect and time. We are accustomed to thinking of time as continuous and irreversible, and of memory as a witness to history. But if randomness can produce complete consciousness and memory, then our trust in the past is shaken. As a result, many philosophers have begun to re-examine the basic premises of existence and self-knowledge, and some have even proposed the theory of the fictional self, suggesting that all of our experiences may be nothing more than a kind of self-deception within the brain. While this idea may sound extreme, it certainly challenges our basic understanding of reality. The discussion of the Boltzmann brain has been the subject of many heated debates in academia. Scholars who support this idea argue that, according to the basic principles of statistical mechanics, the probability of randomly generating a self-contained brain in a universe of infinite or extremely large timescales is much higher than generating an entire ordered universe. For this reason, they argue, any theory of the universe must consider how to avoid the proliferation of Boltzmannian brains, or else it will lead to the observer's paradox, which makes the universe, as we see it today, seem highly implausible. Opponents suggest that the Boltzmann brain is merely a mathematical singularity rather than a real possibility. They point out that in the actual evolution of the universe, there is a complex set of physical processes and causal relationships that are far more important and effective than mere random fluctuations. As renowned physicist Roger Penrose once wrote in an article, while probabilistically brains can spring out of thin air, the probability of this is so low that we will never observe this phenomenon on a meaningful cosmic scale. His words have given many opponents of Boltzmann's concept of the brain a theoretical justification, even if the math allows for such a possibility. The rate of its occurrence in actual physical processes is minuscule enough to shake our belief in the continuity of reality. In addition, there are some scholars who have attempted to provide a new explanation or solution to the Boltzmann brain problem, starting from the perspective of quantum gravity and information theory. They argue that the fundamental composition of the universe and the process of quantum information processing may intrinsically exclude the kind of low entropy, randomly generated, isolated brains that fundamentally ensure the coherence of the observer and history. Such a view not only provides a rebuttal to the traditional Boltzmann brain thesis, but also opens up new ways of thinking about the basic mechanisms of information transmission and consciousness generation in the universe. I remember that once at an academic seminar, a theoretical physicist from Japan said in very funny language, if the Boltzmann brain really exists universally, then what we are discussing in today's meeting might just be fragments of consciousness with a lifespan of a few seconds. The question of the Boltzmann brain is again particularly thought-provoking when the discussion is put into the context of modern cosmology as a whole. As the theory of an accelerating expansion of the universe following the discovery of dark energy continues to mature, scientists are beginning to realize that our universe is likely to enter a near-vacuum, low-temperature, extremely high-entropy state in the future. In such an extreme environment, conventional physical processes would gradually come to a standstill, and random fluctuations would become the determining factor. Some cosmological models point out that in such a long-term, near-thermal equilibrium universe, the emergence of a Boltzmann brain would instead become inevitable. After all, over the course of an infinite amount of time, there would be countless chances for even a very low probability event to occur. It is this, however, that has led many scientists to question, if the future universe will indeed evolve in this way, is our state of being today counter to statistical intuition? That is, if the majority of observers are such ephemeral consciousnesses created by random fluctuations, is our present selves with coherent memories and histories also just an exception to the probabilistic theory? In response, André Linde, a renowned cosmologist, has published a paper that discusses in detail the possible Boltzmann brain problem in the theory of eternal expansion. He wrote, "In an infinitely expanding universe, we must seriously face the fact that probability theory tells us that isolated brains are far easier to produce than entire ordered universes." This passage had sparked a wide-ranging discussion in the academic community, and many had begun to re-examine basic assumptions about time, entropy, and the nature of the observer. Meanwhile, another group of scholars has proposed the so-called anti-Boltzmann brain theory, which attempts to prove that some mechanism can naturally inhibit the creation of such a random brain at a later stage in the evolution of the universe. They argue that factors such as quantum gravity effects, the law of conservation of information, and the boundary conditions of the universe may somehow prevent the emergence of such an extreme low-entropy state, thus ensuring that observers in the universe always come from a continuous and meaningful evolutionary process. Although this idea is still at the stage of theoretical exploration, it certainly provides a fresh perspective on our understanding of the ultimate fate of the universe. In a roundtable discussion on dark energy and the future fate of the universe, a European scholar gave a very vivid example. Imagine if the whole universe eventually becomes a dead-hot sea. Then a brain emerging occasionally in those countless seconds is like a spark suddenly flashing in a glacier, short-lived but exceptionally dazzling. But can such a spark really represent life or history? These words not only made the atmosphere of the scene unusually grave, but also made the participants begin to reflect, how should we define real existence? In fact, in the scientific community, the Boltzmann brain has long been more than just a cold mathematical model, but many physicists, cosmologists, and philosophers enjoy the topic after dinner. I remember a young scholar from the United States once said with a smile, "Do you ever feel that the little experiences of our life may be like a carefully edited movie, and behind the scenes are actually countless random clips put together?" Another older European scholar quipped, "If that's true, then I wish I had flashed a few more times so I could experience a few more lives." In fact, similar anecdotes are not uncommon in scientific circles. Once at an interdisciplinary symposium, physicists, philosophers, and psychologists sat around talking about topics ranging from entropy increase to self-awareness. One of the psychologists said in a half-joking tone, "If we really are all Boltzmann brains, then at least I have this universe to thank for giving me so many spare memories that I have a new story to tell every time I wake up." The stage erupted in laughter, but the laughter also implied deep questions about the nature of reality. What's even more interesting is that a lot of scientists in private gatherings also take the Boltzmann brain to flirt with various oddities of modern cosmology. A Nobel Prize winner once told a friend, half seriously, half jokingly, "I have been worried that one day I will wake up and find myself just a brief flash of consciousness bubble, and by then all my honors, achievements, may be just an accidental hallucination." The listeners were all amused and at the same time fell into contemplation about the meaning of self-existence. It is these real discussions and stories that have made the Boltzmann brain not only stay an abstract theory, but also become a cultural symbol about existence and time, inspiring countless people's infinite reverie about the mysteries of the universe. Many scholars believe that it is precisely because we have a stable memory system and a coherent chain of cause and effect that we can deduce that we are not an isolated, randomly generated Boltzmann brain. In other words, the fact that we can recall our own upbringing, the joys and sorrows we have experienced, is in itself proof that we are fundamentally different from the transient, flash in the pan of the brain. As philosopher Daniel Dennett once pointed out, if you were a Boltzmann brain, you wouldn't have enough history load to support all your memories and emotions. While this view sounds simplistic, it gets to the heart of the matter. Real life necessarily has some kind of inherent continuity that is difficult to simulate with random fluctuations. Of course, there are skeptics who argue that our understanding of memory and consciousness is still too limited, and that in the future, with advances in brain science and quantum information theory, it may be possible to show that memory itself is just a kind of data that can be reproduced by random processes. But in any case, this discussion about Boltzmann's brain has profoundly revealed a problem. Our understanding of the self and the universe may always remain in a state of constantly asking the boundary between reality and illusion. In the future, as scientific experiments continue to advance, we may be able to simulate extreme conditions similar to those in Boltzmann's brain in the laboratory, and further explore the relationship between random fluctuations and the generation of consciousness. Imagine if one day we can use supercomputers to simulate the thermodynamic evolution of the entire universe and see the sparks of consciousness that randomly appear in those extremely low entropy states. That would be an unprecedented visual verification of Boltzmann's brain theory. Although this idea is still far away, it undoubtedly provides us with a road full of challenges and opportunities for exploration. Here, I also can't help but think of what the philosopher Albert Camus once said: "Man is man because he knows that his existence is full of absurdities, yet he still chooses to pursue meaning." Perhaps it is this relentless pursuit of the meaning of existence that makes us both skeptical and hopeful in the face of such cosmic puzzles as the Boltzmann brain. After all, it is in constantly challenging and questioning that we can continue to broaden the boundaries of our understanding of the world. After talking so much, from Boltzmann's theory of entropy increase in the 19th century, to the discussion of dark energy and eternal expansion in modern cosmology, to the philosophical level of consciousness, memory, and the existence of the self, it is not difficult for us to find that the concept of Boltzmann's brain, although it sounds almost absurd, it is exactly the kind of deep reflection on the nature of the universe that can trigger people to think deeply about the thought bomb. Perhaps in the future we can find more direct evidence to prove or disprove the possibility of such randomly generated consciousness. But until then, the Boltzmann brain has become a mirror that reflects our questions about time, entropy, and existence. It reminds us that the universe is more than just the visible and tangible objects in galaxies. It is full of countless bizarre possibilities hidden behind mathematical probabilities and random fluctuations. Well, that's it for this installment. Likes and comments are welcome. Thanks for watching.